So, hey guys, welcome back to the channel. Before ending the previous video, before starting the previous video, we were discussing about a very good concept of machine learning, which is the pillar of various algorithms, right? So, the topic was GD, gradient descent. This video has now uploaded and it is unable for everyone to use, right? So if I just give you I will say a highlight or a recap of what we have done. So we understood what is GD, gradient descent, why, how, and what. So all these three things were clear. So what is GD? It is nothing but your group of I will say the storage where you store different derivatives, so d1, d2 up to nth value of derivative. So that is known as gradient descent. How do we do this? So before how, let's see why. So why and how both are actually related to the same part of the question. So why and how. So why do we need GD and how do we calculate GD? So we need GD, the gradient descent, because if I have a graph like this and I have a point, so I want to calculate the minimum loss, and I also know that the minimum loss of a slope will be exactly at that place where slope is zero. Slope is zero. So when the slope is zero, we get our minimum loss. It is not always that the slope is zero. See, anything I will say the minimum thing is like for any graph, maybe this, that, this, any graph, okay? So what is the minimum value of a graph? What could be the minimum value? Either it could be a zero or a negative value, right? But maximum time it's always a zero. So I am just saying in my words, like when the slope is zero, we get the minimum loss because the concept of optimization under which GD is a crucial part of optimization, and this all things come from the topic of optimization. And why do we need this optimization? Because we know when we have a point from minus a line from minus 10 to 0 and from 0 to 10, and we have around 100 values each, 100 values each. So the total points over here would be 201 to the power of 3. So this could be the total combination possible in this. And we also know that our system takes 10 raised to the power minus 6 seconds to perform a operation. So any operation we do with this, such as we do plus, minus, multiply, or any such operation, it will take that whole combination into 10 to the power minus 6 seconds to perform. So we also saw that when this happens, then sometimes if the data set size is bigger, such as if we have 201 values and 6 column, so raised to the power 6 into 10 to the power minus 6 seconds, then we approximately need 2 years to finish the whole operation and to get the exact line which divides the stuff. So this is what we understood. So we have concluded that no, intuition process is not correct. It's not correct, I will not say, but it is not appropriate. Is a better word for this. It is not appropriate for us. So after this intuition, so this all were under optimization, right? How do we optimize? All were under opti. So then we went to function part. So y equals to f of x. From this function, we understood that if since we know y equals to f of x, so I can simply write this that f of x equals to x square, to which we get a graph in this format. So this is the graph of y equals to x square. Now, if we want to calculate the slope for this graph, so we know that if a line crosses, so this point and this point will be y2 minus y1 by x2 minus x1. So this was the mathematical formula of the slope, y2 minus y1 divided by x2 minus x1. Now since we know this formula and also we know that this will become your slope, and slope is nothing but your derivative, and derivative is nothing but your gradient, and combination of gradient is nothing but your gradient descent. So this is the whole chain which we have found out. Now moving on to the next part. So when we identified that yes, we have a function so called y, equals to f of x square. Since we have this function, I hope this is clear, right? So since we were having this function, now what's this? Limit. So since we were having this function y equals to f of x square. So to calculate and identify the slope, just increase the size, right? So to identify the slope, what we need was we will do f dash of x. We would require f dash of x. So what is this f dash of x? We know it is 2x. How we have calculated this? Either with the formula which we have discussed. So f, 1 second. Yes, increase the size of this thing. Yeah. So how do we calculate this? Either with the formula f of x plus delta x minus f of x divided by delta. So we know how we have calculated this formula, like this 2x. So now what is this 2x? What is this 2x known as? This will be known as my derivative. As simple as that. And after this, what can I do? I can put this, I can actually give this derivative name as a gradient. I can actually give this name as a gradient. Then I can put this gradient into an equation which was x naught, means my old x, minus learning rate of g, right? And this will become my x new, right? So this was what we have discussed about our gradient descent. I hope this part is clear. Right? This part was super clear. Till here we have discussed. After that, I have also told you that why this learning rate is in minus, why not we do plus. So the simple reason over here is when you have a graph and when you take a point, let's say this is the first assumed point, then you take another assumed point. So when you take the first point like this one, then what will happen over here is that one second, I just increase the size of the so that it will be clear. And let me say I am just giving this tangent. So we create one tangent here, another tangent here, another tangent here. Like this, we create multiple tangents unless we reach the point zero, right? So uh, what is zero? Zero is the minimum point. I am again clarifying this. Zero is the minimum point for x square wala graph. X square equals to y. For this graph, zero is the minimum point, right? Before moving to the next part, I would just confirm that. So when this is the tangent and this is the tangent, and I know that my vector will always we from the perceptron concept we also saw that my vector will always head towards upward direction. So if I do a plus here, like plus of learning rate, if I take this, then my next point will not be at this position, rather it will be at this position. For x, so we also saw this with an example, like when I took the value 13 as my x, then learning rate as 0.1, learning rate as 0.1, and I multiplied this whole thing with 2 into 13, so it was 26. Okay, why 2 into 13? Because I had 2x as my derivative, and you know that this value is nothing but your g, so which is this part, and we put it here, so it is the same g, right? So it is the same g, right? So what result we got? We got 10.4 as the result after just solving this. But if I do plus, which we are talking here, if I just do a plus, then what will happen if I move into if I do the plus, that means I am moving into the direction of my vector. That is the upward direction, right? The upward direction. So if I do plus, then what will happen? It will become 13 plus 2.6. So which will be around 15.6. And thus what is happening? The graph which is here and the assumed point which was here, now the assumed point has went up while I need to reach the minimum point of 0. So actually what will happen? I will move into the opposite direction and I will move to the maxima. Not, but my goal is to move to the minima. So we do a minus here, learning rate. And why do we take the smallest of the smallest in the learning rate or the step value? Because we want to calculate at multiple points. We don't want to jump, rather we want to take the step. And that is why this learning rate is also known as step value. I hope this part is also pretty clear with everyone. So now today's discussion. Okay, before moving to that coding also, one more thing I wanted to discuss. Yes. So let's imagine, and this also we have discussed last time also. So still I am just talking about that. So we also saw what is chain rule. We also saw what is chain rule. We also saw what is your partial derivation. PD, right? And we also saw how these are actually impactful when you are calculating your normal derivation, as this all are the part of the derivation. After derivation, we also saw what is double derivation, right? Double derivation. So why do we calculate double derivation? Means f of x is your derivation and double derivation will be f double dash of x is double derivation. And why do we calculate this part f double dash of x? Just because we need to identify the max value and mean value. Just for an example, if you have a graph like this, right? You know this is the max, this is the max, while this is the mean and this is the mean. How? This is the y-axis, so the top y will obviously have a max value like 5 here and 1 here, right? So in perception, I am just saying that. Now we saw the graph, we saw the point, and we confirmed that yes, this so yes, this part is max, this part is mean. But how if you get some different function? So for that we need to calculate this double derivative. So it is well said that when double one second sorry it is said that when double derivative is greater than 0, I think it is maxima or minima. I think it is maxima, and when it is less than 0, it is minima. Probably you can just recheck this part once in maybe in Google or someplace. But but the concept of doing double derivative was this only. So you can just recheck and interchange the value. Nothing else is nothing big thing is in this, right? Now, let me just confirm that till here we have discussed last time. Okay, and is there anything pending? Okay, uh, last thing I will just last thing I will just recall. We also know that we may get some function like this plus 3y plus 15. I don't know, it's probably not working, but majorly this is the line, this line won't be applicable here. Let me say y equals to x. So I think there is some issue. Y equals to x should be this way. Okay, it should be this way. We know how y equals to x looks. So let me just refresh this. Let's see y equals to x. Yeah, now it's working. Plus 3y, great, plus 10. So now you have a function like this. Let me just take that function here also. So you have a function like this, okay? Let's say this is your function. Now you know that we have one x value, we have one y value. So cumulatively this part is nothing but it comes from the part of your partial derivation, right? So This is one thing I wanted to show. Now another thing, like let's say here also it is x. Now you can see how the graph is looking. You can see what is this graph. So, okay, for this graph, what is the, I will say, one concept is there, so-called domain and range. Okay, so this concept is also the part of your optimization, which we haven't discussed last time. So basically, what is this domain? It is just a simple thing. This is called the output, sorry, input. One second. This is called your input. This is called your output. Just for an example, when you had your graph y equals to x square, so x was your input and y was your output. See, because when you put the value x like 2, so y becomes 4. X as 4, y becomes 16. So because y value is dependent on x value, y value is dependent on your x value. So we say input is x and output is y. As simple as that. So same thing, if you see here, and if you just imagine what can be your, if you see this graph, I think that is pretty clear now. So you can see that this graph is not non-ending graph because it goes towards infinity. But since this graph is actually pointing towards zero and then moving towards infinity, so we say the range is from 0 to infinity because it is actually coming from infinity but stopping or trending towards 0, then from 0 it is going there. So the range becomes 0 to infinity, while domain can be infinity to infinity. It is quite clear, right? If I just make this graph, see, one graph is this, another graph is this, and this was your axis. Now if you say this graph is having infinity value, like we don't know where it ends, and it goes somewhere to infinity. Same here also, it goes to infinity, it goes to infinity. So it is pretty clear that yes, it comes from infinity but comes to this origin place which is 0 and then goes to infinity. Same here, it comes to this place and then from this place it goes towards the infinity. So we say the range could be from 0 to infinity, while domain could be from minus infinity to plus infinity. And what kind of graph is this? This is the, I will say, not a continuous graph, NC. Why? Because to draw this graph, I need to lift my pen. I couldn't draw this like this, right? So I have to lift my pen, then only I could have drawn this. So it is a non-continuous graph. So this is your domain, this is your range, this is your type. So I think this is pretty clear. And before moving to the coding also, you can also see here like we have x plus y. So when I just cumulatively take this two part, which is x plus 3y, and now when I want to calculate my g, which was in that gradient equation, so if again if I just write a gradient equation, it was what? X, one second, it was your x old minus learning rate into g, right? And what was your g? G was your derivative. So basically I need to calculate the derivative of this. To calculate the derivative, I have to follow the partial derivation method because I have two variables. So in the first variable, I will do with the x. So I get 1 as the answer because this portion doesn't have a x, so it becomes 0. So 1 plus 0. So the first thing which gets stored is 1. In the second way, x will become 0 because we don't have a y here, and you know, right, the derivation is this, so d by dx. So if x is here, then this will work. If x is not there, such as only y is there for 3y take case, then it will not work and it will become a 0 because it will treat it as a constant. Same when this will become your y, means d by d derivative of the function by dy, then this will become 0 and only this will work. So at the second case you will get only 3, and when this 1 and 3 get stored it becomes this way. So basically 1 and 3, and this storage is known as your gradient descent because you have multiple derivatives here. So I hope now all the concept, everything is quite clear. So let's don't waste the time, and I don't know how to take this out. Let's see. Okay, I can take, I think. Yeah. So now let's move to the coding part. COD coding. So unlike perceptron, the coding of gradient descent is quite, I will say it is quite tough. I will say tough because like how in perceptron you know, like, right, like what we are going to do, like we plotted a scattered plot, then line plot, we merged them, then we created a data set. So you were having that thing, right? Like I have given you the tasks here. They're like, what is task one, what is task two. So we were having those part, but in gradient descent code, it is quite difficult to give the task. Why? Because you will come to know. So I will just give you a glimpse of how the gradient descent codes look like. So you can see here, I have worked on multiple gradient descent code. So today we will be seeing a single function, multiple function also, if time permits. Function, so multiple function as in this part. Yeah, this part. So what is this? This is basically multiple function, and this is basically a single function code, right? See, this is basically a single function code, and this is a multiple function code. Then we will see how the vector heads toward upward direction, like how this is happening, and then what we actually need. We want to go to the minimum, which is this place, minimum. So I can I copy the image? Yeah, paste. Great. So you can see here. Okay, one second. Yeah. So you can see here that if you can see here, right? So this is that line because 0 comma 0. This is that line, and this is that line, y-axis ka line, right? So this origin is somewhere at 0, right? Imagine your graph of y equals to x square is somewhere here. I will make a proper graph, yeah, here. Okay, now since we know the vector were moving up opposite direction, so we have converged them towards the inner direction. You can see all the vectors are now going inside. what is this conversion? Why for? Because we want to the minimum position, this point. Because this is the minimum position which is 0 for my function x square. I hope this is pretty clear. So this we will see how we are going to do that. We are also going to create a simple curve function which is our x square ka function, okay, which is your nothing but your this function x to the power 2. This function using the code like whole this graph we are going to create, right? This thing is nothing but your this one. So we will create that, after which we will make some other functions also, such as here we have created a function of gradient descent. Here we have given the function of delta part, right? And then we will store those values and write some graphical codes to plot this line. Also, in my next analysis, what I was doing is I plotted 2 points here. Then further I plotted those 2 points with different code, and then I plotted multiple points, and then multiple points, and then each point with a tangent. So we will be seeing how this code, or let me say how this code, let me just take this out, not necessary. I say how this code is working and how code was working. So yes, so this kind of stuff we are going to look today. And probably if time permits, then only we can look it into a brief. Otherwise it will take us some time to, because it is already half an hour of discussion. So without wasting the time, let's begin with the coding. So welcome to the coding part of gradient descent, and let's start the coding now. It is connected, great. And let me just start this. Okay, so let's first input our all the things. So input numpy as np, input import it was sorry import numpy as np, import pandas as pd, and all other stuff we are, one second, generate code may be subject to the license. Yeah, I have no, I don't want this, but I just want to here. Great, so this part is done. Now what we will do, let's just go back and see. So what we are going to do here. So if uh, so let so let's do one. Okay. What I am suggesting is, because we have studied about two type of function. One is x square and one is x square plus y square. It is basically the general partial derivation and simple derivation. Okay. So I know this function is bit easy to understand, and then we shall move to this part, right? So let's just understand what graph, how the graph will look for y plus x square. So, 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 this has become the graph, right? So this is the graph kind of thing. If you just if you just could put a value, or it will become 2x and it will become 2y. So if you just put some random value in 2x, so you can say like somewhere 4 and 1. Means I'm saying that once you let me just take this portions out. So now I'm saying that you have this x square plus y square. Okay, so what will be your this derivative? So I'm just symbolizing it as dash. So it will become your 2x plus 2y. I just did it with a partial derivation, simple. Now I just stored it as a gradient. Let's say I'm just storing it as 2x 2y. Okay, now I just put some random value for x and y. Maybe I can give a value such as 2 to x and 1 to y. So what will be my final gradient? It will be 4 and 2. How it happened? 2 into 2 4, 2 into 1 2. So simple. So this is how the graph should look like. If this is the graph, so 4 by 2 somewhere here, then so somewhere this kind of graph probably it should be there. I don't know why Desmos is not showing that, but probably it should be somewhere that way, right? So now what we can do is how we will be proceeding today with our discussion or with the coding. So I will be explaining you each and every code and its line one by one. So first we will be creating a function. So my function this time will be y equals to x square. I'm keeping it as simple and as clean as possible, right? So we will create a function for this part. So let's create a function. So def create my function. So what will be my function here? I will not take any other variable. I will just take this part. So I am just saying that x is my variable and I will return x power 2. Now just see and just check of 4, which will be 16 probably. Great. So this function is working and just take this out. Now after creating the function, what shall I do? So after creating this function, I can do is I will be taking uh, so what can I do is I can just plot a graph first of all. For my specific function, I can plot a graph. So I don't want to write this big again and again. So I am just replacing it with the f. So f of x, this is quite easy for studying also, right? I have just replaced this with the f, right? Now I will create a function here. So I will set that as plotting, right? So what I will be plotting here is x equals to np dot a range of minus minus 10 to 10 with a step value of 0.1, and just see what is my x now. You can see. So let's come back to the step 2. What I did, I took a range of minus 10 to 0 to 10, which we have already discussed, right? So this is what my x-axis. So my x will cumulatively have all the values from here to here, right? So this was my step 2. Now step 3. I will be calculating y. So I know my y is equals to f of x, right? So what will I do is I will plot now x and y with the show, right? I hope this part is clear. So I just have taken this part and kept here, and then my x square was substituted with all the values of x from -10 to +10. So I hope this part is also clear. Now moving on to the next part. I will be creating one function. See, till now what we did, we created one graph, right? After this, what was the first point of gradient descent? Select a random point. So that we are going to do now. And then do the gradient calculation. So for selecting a random point, I need the derivative. So I calculate the derivative. So I'm creating a function like def of derivative. So calculating this function def of derivative. So def of derivative is my function name. In this, I need some code, like quotation I need, right? So the first quotation which I need is my x ka value and my function. Simple. Then I also need the derivative. So, okay, so you know, right? We were discussing now. What is my d? D is f of x minus del x, sorry, plus del x, sorry, f of x plus del x minus f of x by del. So this is exactly what I'm going to do in my step 4, which is nothing but derivative function df. And let me just take this out as well, right? So so I hope this part is also clear. So let's just quickly create that function. So uh, what is my del? What can I keep my del x? So I'm just giving it as a name as delta, and I'm just giving some 1. It is just a random assumption, nothing else, nothing like fixed in my head. Okay. Now I just return this function. Great. So what I did, f of x plus delta x, which is your delta here, minus f of x divided by delta. Simple. Now after this, what I will do next? So the next is your gradient calculation, right? So for gradient calculation, again we can create a function. So def of let's say uh, one step grade. I will just say the name as one step grade. Okay. So in this one step grid, what will I need? I need my X, I need my F, I need my LR, right? So what is my X, F and LR? X is my function such as x square, means okay, F is my Y, means basically F is the function and X is the values that we will be putting in, right? So LR is my step value. Now you know the gradient formula. So gradient formula is nothing but your x naught, which is your old x, minus learning rate of gradient, and gradient is your derivative of function f of x, right? That is why we have first created the derivative of function, which we will be putting directly at this place. So you already have your g ready with you. Step value we will be just looping, so we can just assume that our delta is our step value, which was your 0 point something. So that we can assume as my step value, and x naught already we have, such as in our case -10 is the x naught. Just for an example I'm saying, like seeing this part. Okay, so now let me just clean this up quickly. Great. So the next thing which I will do is gradient descent function. So I'm writing gdf, which is your gradient descent function. Okay. So let's just write the code for that. So gradient will be my this function derivative of what happened? Yeah. So gradient will be my this function because already I have created a function for derivative. I just put that again here. Great. Now my new x will be old x, so which is my x minus learning rate into gradient I, and this is what we were discussing in the formula, correct? And also I want to create this new function as my new x ka value as my function, so I just write it this way, like new fx equals to function of new x. It is all up to you. If you want to just write it that way, you can write. Nothing a big thing here. And I will also return my gradient so that I can see. So this part is also pretty clear. Till here, everything is done, right? After this, what we will do is we will be plotting the whole thing, this thing with the point and a tangent. So my graph after this was looking this way. So this is the main part of the code, so that we could see how many, like we could show someone how this is moving towards this point 0, right? So now, okay, I just want to see how this graph look. Okay, so this is the graph of x cube, right? So if you want, you can also change this to cube and run this and run this. So you get the graph here. So it is all on you, and this point is known as the saddle point because this point is known as the saddle point because from here also you are moving to the minimum, from here also you are moving to the minimum. So this point is known as the saddle point with 0 comma 0. Okay, but since we don't want this part, so I will be doing with the x cube only. But if you want, you can actually check with that graph also, that x cube ka graph also. And how does this look like? Let's just see once. Okay, okay, great. Fine. So now we will be doing the final plotting. So I will head this as final plotting. So see, till here was the main part of gradient descent. Like this was the final code of the gradient descent. Like this is how you calculate the gradient descent. Okay, and this we have done so that we can directly quote the derivative thing over here. Otherwise, if I don't make this function, then I have to write all the two things in this. So it will take the lines, it will take some extra lines, nothing else. So I have given this as a smaller function. Means I calculated a derivative, and according to the formula only I am doing. Like what we have discussed, we are doing that only. Nothing apart from that. So we got this gradient descent now. So what will be, how will I do the plotting? And this plotting in gradient descent is actually quite complicated part. So for plotting, I will just say plt.figure. Okay. Then after this, I will take my this code, which was the plotting code, because I want to plot on my this code, right? So I am just taking this code, the x square wala code, right? And then what was next? So I will apply here gradient descent. So basically, if I just recall you how we have done the perceptron, we made a scatter plot, right? Then we created a line, then we combined them, a line with the scatter plot. After this, we have written the code so that this line was rotating this somewhere here, somewhere here, somewhere here. So this is how it was working. The same thing in gradient also. You have created a graph, okay? You have created a derivative. You have found the gradient descent. Now you are going to combine all of them together into a single code. But here you need some kind of manipulation. That is the only difference. Here there was no manipulation required. Here only one manipulation was you were updating. So for the updating you have written w equals to w plus xi into yi, and w naught equals to w naught plus yi, something like that you have written. So this was the only updation you were doing here. But here, since this is a kind of graphical graph, means a kind of plotting, you are going to do a visualization kind of stuff. So here there is some challenges in the updation. So once you understand that challenges, actually you can apply this in any graph first thing, and you can actually change those I will say those code also up to like up to your own creation, or I will say creativity and all. Now let me just apply this here. So I will apply the gradient descent now. To apply the gradient descent, I already have created one function here, right? And I know what will I get from this function. I will get this values from this function. One second. Yeah, I will be getting this values from this function. Great. Till here, I think it is pretty clear with everyone, right? So also, once I get this values, right? So what will be my this values basically known as nu x, fx, and gradient. So all of you agree with me, right? So when I have a graph, I get 1 point, I get 2.3 point, 4.6 and 7, and I get multiple point unless I reach the slope at the 0th position, right? So now you know what is x mu. This is your x mu. Let's assume that, right? You know what is your function of x mu. Means what is function of x mu is what? Nothing but the same, the value which you got, right? And you also know what is the gradient. So everything, the function x nu and gradient will be for this specific point. Everyone agree with me, right? Now when we move ahead, so definitely I will have one more point here, I will get one more point here, I will get one more point. So each point will have three different things, because that is what we are showcasing in our result, isn't it? So am I supposed to store this points at in a list so that I don't need to repeat the whole calculation again and again? So for that, what will I do is I will create a storage house, let's say storage house. Okay, so in this storage house I will be assigning some value. Let's say my x naught is -5. What is my x naught? X naught is -5 means when my graph is this, okay, so this is, let's say this is -5. Great. Or let me just give you the proper thing. This is your x and y axis, so let's say this is -5. So let's say this is -5, okay, and from here I'm moving, and I will reach at this position. So we are actually focusing on this side this time. Let's just assume that way, right? So now let's just work on that. So I have assumed a value of -5. Now I need to store my all those values as well, right? Okay, what could be my jumping, like what, how much I want to jump? So let's say my first jump was nothing but a 0. So num step I am just giving will be 0. Let's just assume that. Now fx means xs. is what a blank list I am giving. Okay, f of xs is what again a blank list. Okay, and grade is what again a blank list. So basically, what is this blank list for? For the blank list is for these three things which you will get after applying your gradient descent into the code. I guess this is also pretty clear with everyone. So since we are at the 0th position, so this become my x of 0, and then I just append all of them together and then just run this, and then we get a issue this way. So why LR is not defined this way? This is the code. Array, yaar, 1 second. This code is not haven't run, I think, but I have run this code. Leave it. So now you can see that we have quoted this graph into this. Array, what is happening? Code is running, LR is not defined. Just give me a moment. I just want to check. Like from yesterday only it is happening. Some of the function code is not running properly, it seems. Sure. So you're saying the LR I can keep at 0.1. Yeah, it is up to me. I can actually keep it at 0.1 or not. So let's just don't worry for LR. I will tell you why. Okay, in the upcoming means I will just tell you why when we move ahead with the code. So we got this code here. We have written for the this gradient part, and now comes a very interesting guys point over here. So I will just uh, take all these things out. Now I know that my line equation is y equals to mx plus c. Okay. So what will be my c? C equals to mx minus y. If I just rewrite this, I can write it as y minus mx. Clear? And proper note is y equals c equals to y of minus x or y minus mx, right? So now let's understand why I have written this, and let's just write that line as well. So this is the line code which I am writing for line for tangent. So what is the tangent? Tangent is your black line which touches the slope or a graph at a single point is known as the tangent. If it would be at a multiple point, then it would be considered as a line. So you can just keep it this way. A single point matlab tangent. So line for the tangent. So the line for the tangent will tell me that C, let's say PC equals to y minus, okay, mx. So this is the line for the tangent which we have derived. So how can I rewrite this formula? So I am just assuming a variable for c means for my constant which is pc. I know y as we have discussed this. So what was my y guys? What is y? Isn't my y is equals to f of x, right? So till that only we were writing, right? So y equals to x square. Matlab f of x equals to x square. So this part I have given here. So my y becomes f of x, right? Now what is my m? M matlab what? Slope. Slope. M means slope. So slope means derivative. Derivative means gradient, and we already have stored our gradient in grade, this function. So grade is something which we have created and it will be storing n number of gradients till we get the final point. So can I say gradient of -1, which is the last value, will be my newest gradient? See, just imagine if you have a list, let's say 1, 2, 3, 4. So what is the last value of this? Which is 4, right? So basically, if 4 is the last value, then can I say the performance or or I will say this as I can just reword this as the action performed in this code or with this code, such as I am just writing 1 plus 1 will be my next number, which is 2. So this thing, when we perform certain operation on this, then the final value which we get is the last value and the fresh value, also the new value. So the last value is, how do we take the last value, extract the last value from a list? It is -1, right? Because this is -1, this is -2, and so on. And from here, if you start this 0, 1, 2, 3, and so on. So I am just taking this part. So I can I say this as my grade of -1, right? And then what will be my x? So x we already have included in the function, which is this part x naught, because we are starting from x naught now. That is the first assumed value. So can I not say this as x naught? Great. So now can I, now I think my y equals to mx plus c will be looking this way if I just rewrite it in another format then. And won't I say the new format will look exactly like this? So how about if we put the same thing directly here? So f of x naught minus grade of -1 into x naught. Now after I get my c, that is the constant, which is the intercept, I need my x and y value as well, right? So I will say the x value as np dot a range, where my x value should start from x naught to minus delta. Okay, then it should also end at x naught plus delta, and 0 0.1 is my step value I am taking. Now I will just write py as my grade of -1, which is my mx plus c. I hope this part is also pretty clear, right? So I think this part is also clear now. So let me just recheck. What was my that code? Yeah. So see here. So till here we have done. So I will just give this code so you can also see a line now. Okay, probably it's not coming because I think some. Okay, otherwise just take it as 0 0.1 here. So that problem is only solved. Now, what is the issue here, delta mein? One second, give me a moment. Oh, where is my delta? delta equals 0.001. I have mentioned already, then why it is not showing? Okay, so again we need to take a delta here as well, so I can see as we have done here. So I will be taking a delta, a random delta I will say. So delta equals to 2. So now let's create a line. So probably the line is not yet visible. Mhm. So this should be plt dot show. And, hmm, okay, clear, and just take this part out. Now you can see we have a graph, we have a graph with a tangent, right? Now what is my next point is, means what I am going to do next is I am going to give this first code here. Let me just take this code directly from here. And okay, what is the name of this code? So means what is this code we are going to? So now we are going to do plot the points on the tangent. Okay, so for plotting this point on a tangent, what we will do is we will say for I in the range of I think I can take the num this directly from here itself, because anyways if I write it also not an issue, but if I just take and I will just show you quickly because it is already extending. So this is the first thing which you will be getting. Okay, now if I just take this to codes as well and put it here and then just run this, so you can exactly see 2 points. And if I want them also and I just plot this, so you can see multiple things changing at a time, right? Now let's say I you want to see this green point also. So for that, what change, a single change which I will be doing here is I will say my LR equals to 0.001. Now you just see how the part will change. 1 second, and this is the final code, right? You can just see now my 1 point is not there, and you can also see the value of your x new, which is minus 3.33. So what I did actually, and 1 second, if I just do this, now you see what will happen. So all the points are not there because the this portion this thing I have written. Okay, if I just remove this and I just remove the for loop and I just run all the three code at a time, then you will see what is going to display in front of you. That is that I yeah, this one. No, so okay, just remove this. Let's just remove the first point itself. See, still you are getting a single point. Why this single point is happening? Because here you have limited your LR to this value, and which we don't want. So I am just taking this from here and then running this code, and now you will get 2 points, right? If I want till multiple point, I can run a for loop like this part, If I want this type of graph, then nothing. Just after your applied tangent, like this portion where we have created the initiated the value, the variables and all. After this, I run the for loop before this itself, like from this part, and I just place the point x naught and f of x naught. What is f of x naught basically? If you remember, it is your y, nothing else. It is your y. So I just plot x and y. Here x is x naught and y is f of x naught. Simple. And I just give it a constant. So my max iteration is over 100 here. And I will stop at which place where my f of x new means which is my new x is less than my threshold value. So threshold value is 0.0001. So I'll just break that and x naught will become my x new, and then this code will become this way. So I hope till this everything is pretty clear, like it is well and good. I hope it is pretty clear. So I am not explaining like how to write this code and what I have done, because that is something which will obviously come with the practice. So you can just see this code of mine, right? And you can just try it yourself also. And if you want to just change some color and all, you can also change the color and all, and the size, marker, everything according to you, you can just do. So if I just show you what is the, let's do this thing 1 second. So you can see that this red color thing now is the old point, and this yellow thing, the yellow dot, is the new point. So same thing, if you put the for loop before everything, means before this part itself, and just remove the tangent part, because if you put along with the tangent part, no, it become very clumsy, you see here. So here what we did, we just forget about this for loop. So till this part everything was clear, no? Like we have taken all the same variables and then we have given that this thing. This is the part I'm talking about, this part. So this is that part, same part only. Now after this code, I have just given the plotting, direct plotting for the red dot, this dot. After that red dot, what I did, I created a tangent. The same code for the tangent, this part, right? After creating that tangent, I have just same thing I am doing, nothing else. I have then taken this part. I have just append the values. After appending the values, I have given a full stop. That is a break where my threshold, if threshold is greater than new x naught, means the new x naught, then stop. And then print the final guess in orange. So this was the final guess. So what was the final guess? So as we have no in xs, which is the storage of my gradients, the last value will be the final value, right? So which will be 0. So it means you are coming from -5, then getting 1 point, then getting 1 point, and at the end you are going to the 0th position. So this is the same code. So this was the code for your gradient descent, right? And this is quite important because it is, I have told you, right? So do not get scared or think like, okay, what is this big code and all. So till here I have nicely explained you, because till here it was the main part. After this, it was the complementary part, which anyone of you can easily get into this, because see, x naught is the first value, xs minus 1 is the last value. So you are plotting the first value, you are plotting the last value. It is as simple as that. So when you keep this everything in a loop and you just keep a condition with a threshold value, let's say you have given a threshold value of 0.100 times 0 and then 1. So if x is becoming greater than that, then just stop. Just stop. That is what you have done. And here you have given a delta of 2. So delta of 2, will be obviously, if it is minus 3, so it will be minus 1. So this way only it goes, right? With a 2 points thing it is going, right? So you have only 2 points here. We have just showed 2 points. So this part is pretty clear. Now, after this part, and also let me just tell you, if you have any issue in this code, any problem where you are facing, you want clarification and all, then please let me know. I will be sending directly this. If you message me in the LinkedIn, I will be sharing this collab link with you directly so that you can take your own time and you can prepare yourself for this gradient descent algorithm. Now, after this, let's come back to the one of the key thing. Okay, let me just inform you about this, that this code is not the part of gradient descent, so you can be a little bit relaxed now, right? This code is not the part of a gradient descent. No one is going to ask this code to you anywhere in the exam, but just to make you understand that when we have a graph like this, the vector always points upward direction. We have created this exclusive graph for that. So rather than, I think because time is already, uh, it has been elongated a lot. So rather than just explaining this part, mm, let me see if it is quickly possible, then I will write the code in front of you so that, okay, let's write the code then so that it will be pretty much clear in, so that you will also like that code a lot then. So for that, what we will do is, let's create a partial derivation. And if you are reaching at this point of the discussion, no, so just remember that this is not the part of your gradient descent, right? Gradient descent we have completed here. We have found the gradient descent. It is completed here. Now what we are doing is we are identifying how you will work on partial derivation, how you will work on this, that. So some basic things we are just checking. So do not get means I will say, do not get confused with that part, and so so be careful, right? So I hope you have understood what I want to say. So now let's just create this partial derivation. So def of, uh, let's say, get partial. Okay, so here in get partial I need two things, one function, one x, one y. What happened? Okay, yeah, so I need two functions. So now I will create a delta here. So let's say my delta is 0.45 times 0 and then 1. So you know what is the partial derivation of x and y together, right? So first you will write for f of x. So f of x will become now your function, this part, and f of y will become function of the next part. So you just return that value. What is happening? I think some code issue was there. Not an issue. Okay, I have written that f of bracket maximum, so for that it was the issue. Not no problem. Fine. Now we will be working on this function. Let's say now we will be taking. Okay, let me just clean everything out from here. Let me just take out here. So I will be taking one function x square plus y square. Okay, so partial derivation we know it will be 2x 2y. Now if you just put some value, let's say x is your 2, y is your 1, so you get 4 and 2 as the GD, gradient descent. So the same thing I'm going to do now. So I will create a function again. So def, see, I have created one function here. I have not created, I have just given the name as function here. So I am just going to create that function now. So function of x comma y will be return x square and y square. Create. So done. This till this part everything is clear, right? So let's just test our function. func comma 2 comma 1. So what should I get now? Just see. Yeah. So you can see exactly what we have discussed. 4 and 2. So till this we have calculated. Now let's just erase and bring space for the new things to come. So I hope till here everything is pretty clear. Now what we will be doing here is we will be creating a mesh grid here. So what is my mesh grid? Let me just tell you that. You remember there was a game like this, considered all the line are equal, okay, means in the same size and all. Yeah, yeah, there was a game called Bingo. So you give your name like 1, 2, 3, 4, 5, then some till 25 numbers you give, right? So that whole chart where you created 25 boxes, if you just extend and elaborate, means you just feel think that this whole thing is filled of that 25 boxes wale size mein, like we are just covering this whole sheet together at a time. So how it will look, it will look basically like your graph sheet, right? So that graph sheet is nothing but known as your mesh grid. So that exactly we are going to create now. So for creating the mesh grid, I have a function called np.meshgrid from NumPy library. So I'm going to use that. To create that also, I will be giving some assigning some values such as x is 1, 2, and 3. Okay. Y, let's take y also as 1, 2, and 3. Okay. Now let's just create the mesh grid. So np.mesh grid of x and y. So what will happen is you will get a combination of this x and y in array format. So this is x ka and this is y ka. And what is the shape of this x and y? Basically, if you see 1, 2, 3 has become now 3 into 3. Basically 1, 2, 3 and 3 rows. So again same thing. So basically 3 rows, 3 columns. So the shape has become 3 into 3, row into column. So if I just tell you that I am assuming a value, let's say from 20 things. So let's say I'm just assuming 10 to minus 10, and I am assuming there are 20 different numbers. So probably what will be my shape here? Same, right? 20 into 20, row into column. Great. I I think this part is clear. Just just check this. Okay, what will be the shape of this? I have twisted something for you. So now let's just give what we have discussed right now, right? Let's just give the same thing in the graph now. So def of get grid ka function I have created, okay, where I will be saying x equals to np dot linspace function I am using, and I am going to give, one second, minus 10 to 10 to 20 values, and y equals to in space, and then the same thing I will give. Okay, then I want to give the name of my this mesh grid. I want to give some name, right? So I have just given this name and I'm just taking this out. So G1 and G2 is nothing but my mesh grid ka thing. So if you just test this, okay. So let's say before testing now, I just want to see my G1 dot shape. What is my G1 dot shape? So G1 slash s comma G2 slash underscore s equals to get grid. Let's say that, and then if I just say G1 slash s dot shape, G2 slash s dot shape. Now see, we talked, right, it will be 20 into 20. So this is what I wanted to show you. uh, if you are in this video till now, then obviously you have gone and you have rechecked by pausing my video. I also know, so it is 20 into 20, right? Now after this, what I can do is I will be giving the codes now. So the main code for the stuff. So I want the complete attention over here, because this code you will not find anywhere else also. This is a special code which we are going to write now. So let's write the code. So get derivative. I'm just giving some random name so you can just, and I'm just saying that function g1 g2. So my G1 and G2 will come from this get grid wala thing, okay? Right? So now I will say U as I'm just assigning one value. So np dot zeros, okay, of G1 dot shape, and V is so. Let me just explain you what I have written here. A couple of minutes ago, we were talking that it will be 20 cross 20, right? So just imagine this is that grid. So now my each grid with each row and column, okay, will have 0 fill in it, and that is what we do with np dot we do with np dot 0, right? Why it is not happening? Yeah, np dot 0. So this is what we generally do with np dot 0, right? So I think this part is now clear. So all the columns and rows are filled with 0. So for the x-axis, we have assigned u as the uh, u as our alias name. For the y-axis, v is our alias name. So I hope this part is pretty clear with all. Now, uh, let me just take this and actually write that what is my G1 and G2. So just imagine I have my G1 as 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. I have my G2 as 1, 1, 1, 1, 1, 1, 1, 1 and 1. Okay. Just consider I have just two array. Till now, just consider this. Just forget about that 20 cross 21 thing. Just Just focus on this now. Okay. So after this, what will I do is I will write a for loop. So for rows id, basically I am repeating this rows id, basically I am saying. So this is my I loop. For ka this is my I loop, comma rows x, comma rows y in numerate of zip of this part. So what I have written here, let me just take this also out now. This also out now. So let's just understand now what I have written here. So my row ID in rows X and rows Y. Okay. Zip of G1 and G2. So first let's come to the zip part. Now we are going to start this code from the reverse direction to understand what is written in the code. Okay. So let's come to the zip part. Now this is very crucial and you have to understand this so that it will be implemented in different codings when you go forward. So G1 and G2. So the zip of this two, G1 and G2, will be this 1 2 3 1 1 1 1 2 3 1 1 1 1 2 3 1 1 and 1. So this is now zipped. Okay, this is now zipped. So now what will I do is, now I will be understanding what is row X and row Y. So row X is my this part, row Y is my this part. Okay, so I am just writing it here again, 1 2 3 1 1 1, right? What is my row ID? Row ID is my this number, which is 0 1 and 2. So basically my I is now at 0. So same, my J is also, which is my column ID I am replacing over here, is at 0 now. So this 0, which is my J. So J of X and Y. Zip rows X and rows Y. So if I just say zip of this, then simply I just put a bracket here. Now it is zip, right? So now when I say X and Y, so what will be my X and Y in from the zip function? So this will be my X, this will be my Y at the position of 0 comma 0. So X is 1, Y is 1. Then what will happen? X, then it will be 2 and 1. So then it will be 2 and 1. Then it will be 3 and 1. So with respect to your when you move ahead, with respect to that, these values will be also changing from this, then from this. Means first this row, then this row, then this row. So that is what we have written here. After this, what I am doing is I am just introducing my function back to this position. So I am writing f of xy is the same function which I have introduced here. Get partial. So once I get that, I am just updating my u value and the v value, and I'm just returning uv and just running this away. Great. After this, what I will do is, now the concept of plottings come to the picture. Okay, so I create a function def of plot gradient, right? So I have my g1, I have my g2, I have my u, I have my v from the above function. I have my figure, I have my axis, these are my allies name. I give them as plt.subplot, okay, and then I say axis dot, one function is there, right? So it is known as QUI VER. So this is the function that you generally use for creating such scenarios, such cases. Now let's just see how it looks. So G1 comma G2 equals to get grid function which we have created, right? U comma V equals to get derivative function which we have created, and then we just plot them out. And at the end you get one big error. So why this error has happened, let's just see. Just a moment. It is pretty completed, and I think this is a very long video which we have also created, but with this video, when this video ends, all your subplots. So when this video ends, all the concept of your gradient descent is also fairly completed. So you can see how this is going outside. Now to make it inside, I will just put a minus in front of u, minus in front of v, and I will just run the code. You can just see how it has worked. Great. So I think now it is pretty good to go. Your algorithm 2 has been completed, which is your gradient descent. This video probably you will find tomorrow, uh, or like let's wait for a day. After a day, I will put on Thursday. Today is what? Tuesday. Thursday is 23, right? So yeah, let's keep a break till tomorrow so that you will also, people who are observing it on a daily basis, so they also need, like today's we have uploaded the first video, no, of the calculation of mathematics. So let them just go through that. Take 2 days ka time, today and tomorrow. Day after tomorrow, Thursday, you will find this video, the coding part, and then you can take a lot of time, because after 2 or 4 weeks later only I will put another machine learning algorithm, not now, because these codes are necessary to understand. So I hope this for loop is clear, right? If also it is not clear, no, you can just get back to this video and just put some reverse in this video and just see what I have explained here. Definitely it will be clear with you also, right? uh, Probably that's all from my end today. Hopefully you have enjoyed the video a lot, and if you want this collab notebook with you, so please ping me in the LinkedIn, and I will just share this. No doubt I will just share this with you, okay? And also if there is any doubt, any confusion, any problem in today's discussion, please let me know. I would be very happy to understand, and if possible I can also suggest something to you. So hopefully you have enjoyed a lot. Um, Please watch this video and learn a lot. So this was a very important algorithm, gradient descent, a part of optimization, a pillar of machine learning. Hereafter, all the machine learning algorithms that we will be doing, let's say regression, logistic clustering, anything we are going to do, prediction, anything we are going to do, gradient descent will be used. So keep that thing with you, and yeah, let's end up the video. uh, I had a good time talking to you all, so take care, have a great day. And please do like, subscribe the channel, ping me again. I'm saying ping me or comment in the session if you have any question with you. Have a great day, guys. Take care. Bye.